My name is Dmitri Dorofejev, and I'm the Java team lead in the Playtech live games server platform. So what we're going to be talking about today is the cross-platform protocol design with Google protocol buffers. So a few questions just to break the ice. Any Java developers here? Good, good. Has anyone used protocol buffers before? Okay, so small handful of hands. So I think it will be interesting and the whole presentation. So just a small introduction, the protocol design complexity can be compared with the complexity of designing good APIs, because you have to take into account business requirements, technology stack, team knowledge, message size, performance, sustainability. So any decisions, or good or bad at this point, will impact your future development and the communication with the clients. So first of all, small presentation how we use protocol buffers at Playtech. So first of all, we're using protocol buffers to communicate with our clients. We have Flash clients, HTML5, mobile. With Flash clients, we're using binary version of the protobuf. With our HTML5 clients, we're exchanging JSON over the WebSocket. So when messages reach our cluster, they will connect or be routed to one of the services, and internally we also use protocol buffers inside our cluster for the entire communication. And on the right hand side here, our deal applications, which are not publicly available, again interface with our platform using protocol buffers in a binary form. What is good about protocol buffers is the size. Message size is small and therefore very performant. So now let's go on to a small introduction to actual protocol buffers themselves. I'm not going to be talking about version 2 of the protocol buffers, because not that long ago Google released version 3, which is a lot better. It has some better abstractions, data structures. So keeping that in mind, today's presentation will focus on version 3. So what are protocol buffers? First, this short sentence describes it. It's a framework to serialize and deserialize structured data. So what this means is that you can write a sort of a pseudocode, which is language neutral, platform neutral, and then it can be compiled to any target language. So let's say if you want your protocol buffers to work in Java, you take that pseudocode, you compile it, and the result are Java classes. Same goes for other languages like C#, C++, JSON. So this is the biggest advantage. And of course, because of the small size, protocol buffers are good for different industries where performance is critical, like financial, gaming, IoT, and industrial systems. So how does the protocol buff actually works? First, developer will write their definition of different messages in a file with the proto definition. There's not that many text editors available, but in IntelliJ you can download the plugin, which will do all the syntax highlighting for you and also shows if there's any errors or you missed some important keyword. So that will be a big help. So next step, once that's done, depending on how your project is built or how your project is organized, let's say if it's a Maven project using one of the available plugins, either ProtoStuff or ProtoC, the proto files can be compiled into a target language. I will show later in a demo and examples session how it's done. And let's say if you're having your proto files in a separate repository and you're working locally with them, you've written your proto files, you compiled, Java classes are readily available. And also what you get as a benefit of those classes, they're very structured. So you're going to have builder pattern implemented, they will be immutable, and also having some helper methods to check whether some values are set or not set. Right now you want the Proto.C compiler is the default given to us by Google, but it's not very convenient to use. The Proto framework, which is maintained partly by actually colleagues in our team, is I would say more convenient to use. It has Maven plugin. Contents of the files can be extended. Like if you want some specific code in your Java files, then you can write templates for the Proto stuff for Maven, and your Java classes will have the necessary methods. So here I'm gonna try and show most of the data structures and keywords or some other options that the protobuf gives to you. So first line, as you can see, it says syntax proto3. This is really important because from now on, our compiler will know that we're working with a protobuf 3 and not protobuf 2. The keyword option, it's a command to a compiler. So let's say you can, when the compiler builds your classes, it can put them into a specific package. If you, let's say, you hold your proto files in a package called com playtech game proto, then the resulting classes can be put into a completely separate package. Each of the proto files can be imported from each other. So let's say if you have some common abstractions like enums or message types, then you can reuse them in other proto files just by using an import statement and including the proto file. Some of the examples here will come from our background here, so I tried to make them as generic as possible. We start with message, with word message, and then we put the name of the message itself. Then you can define different fields. So string corresponds to string in Java, int64 it's a long, int32 is long. You can use comments, so either single line comments or multi-line comments. Very interesting feature is the one-off. So what one-off gives to you is that the serializer and the serializer will always expect one of the payloads. So in our case, in our games, we have different types of clients and we have players playing different tables. So we always expect one of the payloads to reach our server, so whether it's blackjack, roulette, baccarat, or some others. Also very important, the numbers you see after the equal sign, these are so-called tag numbers. They're used when the protobuf messages are put into binary form and they go to wire. The tag numbers are used to order the content of the message. So what you see here, the actual message batch response, that doesn't get serialized. What will get serialized is the actual content of the message. And the order of the tags defines the order of how those fields will actually go into basically in your connection channel with the clients. Some more abstractions here. The multi-line comment looks very similar to a Java language. The keyword repeated, it's an alternative to list. So repeated keyword here will end up being a list in Java classes. Int32 and the deprecated true. What this means is that it tells the users of the protocol that this field is deprecated. This is another feature of the protobuf, that let's say if you stopped using a field, or you're saying for clients do not use it anymore, then you mark it as deprecated. So in your Java classes, this will end up being with the deprecated annotation. So here I'm just defining the messages that were in the one-off section. The keyword reserved. Sometimes it may be necessary, or you want to delete a message, but you don't want anyone putting non-compatible types in there. So you just mark it as reserved, you put the tag number, and then no one else will be able to use it. Like, let's say server developers, they want to put a new message type and you reuse tag 50, you basically prevent them from reusing this tag, so that old clients will not break in production. Booleans, so we can define Boolean fields. They are always false by default, but you can put the default value as true. Enums. Very simple language to write enums. You just use enum keyword, name, and the list of enums. It's considered a very good practice to add a default enum, which will be with the tag 0, so that in your code you can always check. Sometimes you can use unknown here. So let's say a client sends to you an enum which you don't recognize, you can fall back to unknown. Or if it's not set, then it will also be unknown. And the last thing I wanted to show is the map. So again, often used and very useful feature. You can define maps in protobuf. Important comment: since the classes are immutable, it will return an unmodifiable map. So if any of the developers tries to modify this map, they will get an exception. Next, protobuf not only supports messages or Java classes, it also supports definition of services. So let's say if you have one microservice implementing service 1, service 2, another microservice with service 3, 4, and 5, and so on. You can also describe the services in the protobuf syntax, and it will get compiled into Java interfaces. So the keyword here is RPC, so the services will be RPC style, which means they will return a future. They are non-blocking. I just think it would make sense to use blocking services here, because that just would block your clients from receiving the response. So here we have a request type and response type. That's it. I've left them empty just for sake of brevity. So also what this saves from you is from writing boilerplate code for your services. You just get interface and return types for free. Small introduction, what actually happens after you've written the proto file, compiled your Java classes, how they actually get transferred to your target destination. Essentially, a message is just a series of key value pairs. So if you take your string name tag number, this will end up on a binary form where the tag and the length of the message will be at the beginning and the message content after that, and so on. So the messages are strictly ordered in the order of tag numbers. The very important sentence is the last one. The name and declared type for each field can only be determined on the decoding end by referencing the message type definition. As I said earlier, the messages themselves, they're not transferred over the wire. So you have to provide the deserializing part with the message type. So either you need to wrap your messages into a wrapper code, or you just add another field into your message with the type name. Tags are unique identifiers. You cannot have tags with the same index. The messages won't compile. Another interesting feature, default values are never sent over the wire. So let's say if the sending side will not set an enum or integer along, that doesn't get serialized, but the deserializer will still return you default values when you request them. And another important aspect, protobuf messages are not designed to handle large messages than 1 megabyte. I would like to see anyone writing a protobuf message larger than 1 megabyte. It would be huge. So for this, you need to use streaming. So an example how it looks like in binary form. The example are pretty simple, but give an idea. So here we have message test with the int a with tag 1. So when we give a value of 100, this will be the binary representation. Tag number is converted to 08, and then the value goes next. For strings, it's a bit more complicated. For strings, the serializer also adds a length. So in case of integers, the tag number acts as key, and in case of strings, the tag number and length will act as key for the serializer. A few drawbacks of the protocol buffers. First of all, you cannot do inheritance. Why is this important to understand? It's at the design stage, so that you know that you cannot extend any classes, so that you have to use nested classes to add all the information. And of course, messages cannot be too big. Otherwise, serialization and deserialization will just take too long and your performance will suffer. Any questions so far? Am I going too fast? Or the pace is okay?
Yeah, I have a question about type safety.
Yes.
So, what happens if I describe a message? Can I specify that this field is required? Some specific.
That's required?
Yes.
In Proto 3, no. There's no such word anymore. The Proto 2 used to have a keyword called required, but that was a big, I would say, negative side, because it's basically forced you to always send this message to your clients and never remove it again. So there is no special keywords in front of your field. You just type and field name. And it's up to the contract with the clients whether clients expect this message or not. You have to collaborate with client developers a lot, or with users of your protocol.
But the clients that actually get generated, pretty much everything is optional in this?
Yes.
Okay.
Not pretty much, not everything.
Everything is optional, but it's important to talk to the users of the protocol. You have to consult them. This is all going to talk on my next slide. You have to consult them, tell in which case the message will be sent and in which case it will not be sent. Yes.
Can I specify the string encoding when I send the string, or some default encoding assumed always?
There is a default encoding in protobuf. It's using variant encoding. So if you just say string, then that's all you can say.
Okay, so it's UTF or how does it know?
How does it know?
Yeah.
I guess for this you have to go into protobuf code itself and read a bit more, because I haven't actually checked on this topic. Yes. Okay, so cross-platform protocol design. I've outlined some of the general principles. So I would say one of the very important ones is make sure team understands how protobuf is working, because that is crucial. Of course, all the protobuf changes would pass review by client developers, server developers, but it's still important to understand what is happening when you write the message and what will happen when the message will go into wire. Because sometimes you can change types. So let's say scalar types are compatible, string types are compatible, but you need to understand what you're doing. So protobuf documentation, how it gets compiled, very important to know. Next, communication between server developers and client developers. Again, server developers shouldn't be writing protobuf files on their own unless it's inside the actual platform. So as soon as the protocol goes out, it needs to be consulted with the other developers, because this is pseudocode and everyone understands it. Follow consistent naming pattern. I'm gonna give a few examples where it's actually bad examples. Let's say if you use word get in some places, and then you start using obtain. That's confusing, don't do it. Or let's say add and include, or success and successful. So try to use short names and consistently, otherwise there'll be confusion, misunderstanding, people just will forget the purpose of the messages or fields. Message and field names must be self-descriptive and single purpose. I think the best example of the message or a field name is that when it doesn't require a comment in the protobuf file. Of course, it may be, a comment may say why this message was added, but there shouldn't be any comment saying what this message actually is. Otherwise, the name is wrong, you have to change it. Clear comments and change log. So whenever you work in a protobuf or on the protocol, always write comments why something was added and the changelog file, because this is going to help other developers to see what you did, why you did it, and also will help client developers as well, because client developers will have access to the raw proto files because they need them to compile it to the target platform. And every component in the ecosystem must be aware of its current protocol version. So server needs to know its protocol version, clients need to know that. Any other applications reusing your protocol files, they need to know the protocol version because they need to update it and to receive the latest updates. And let's say if client communicates to the server, then they need to send the protocol version because the server will act accordingly. Yes?
Does it mean that if you want to bump the protocol version, you need to bump it everywhere at once?
Not necessarily. Changes to protobuf are backward compatible.
Okay.
It's a no-no to break backward compatibility. The important factor is that server has to be newer than the client.
Okay.
Because server will always support some new fields in the protocol, clients will still use the old fields, everything works. If for some reason, new client, old server, there will be an exception at some point. This is more like a general principle, but still applies to protocol design. Keep clients simple by sending all necessary information from a server. Don't let clients do any weird calculations, anything. Whatever client needs, send it. Create clear abstractions for messages that need responses and for messages that don't need responses. So, as a rule, all the messages, requests will need response, even if it's empty. But there may be situations when, let's say a server needs to push something to the client and doesn't need a response from the client because networks are unreliable, you don't know, maybe the message didn't arrive. In this case, create a separate abstraction and call it notification, for example. Then you know that whatever message is called notification, that will not require a response. So I already mentioned networks are not reliable, especially mobile networks. So from this unreliability comes the next point, it's idempotency of the messages. Quite often, even in our example, when the player plays at the table, player gets disconnected. So if player sends us some request, we need to be able to handle it in a way that we understand that the player just continues his table session and that's not some new message. So idempotency is something that needs to be considered. So the best practices here, you add some generated ID by the client, which server can check, so that you don't depend on the actual other content of the message. Automation. Automate protocol build and release processes. Do not do this manually, because again, you will run out into different weird situations. So whenever change is done in protocol repository, create a release version that can be already used by the clients. So the good practice here is whenever something gets merged into protocol repository, it becomes a new release and can be used by the clients straight away. So in this case, master is always a stable branch with the stable changes. Versioning. Just wanted to mention that versioning must be done from the day one. The versioning pattern is up to the team to decide, but it just needs to be understood by all parties. So server, client, they need to understand where the versioning is coming from. And of course, every change of the protocol must end up in with a unique version and release artifact. Depends on, can be RPM, can be a zip file. Changelog, very important from my experience. The changes need to be well commented. Either you can use some identifiers from the project tracking system like Jira, or even a link to a Confluence page, whether we're using Trello, for example, that needs to be added. And each of the changes need to be seen that they went onto a certain version. So it's not enough to have a big changelog without showing the versions where the change was made. So developers, when they look at the changelog, they need to be able to understand when the change was done. Automated protocol documentation. The protostuff compiler gives you this out of the box. So what this means is that whenever new change is merged into protocol master repository, and let's say it's picked up by your Jenkins process, the documentation is built that can be reused by all interested parties. They can check the content of the messages, the new fields, and the versioning. And the poor change log will lead to misunderstanding of the protocol and developers forgetting purpose of particular fields or messages. So this can happen. Let's say if you have protocol which is many years old, and let's say you have clients who are 2 years old in production and you still need to support them, then it's important to have clear change log. Okay, so now we're coming to backward compatibility. Sorry. There's lots of do nots in this list, but don't be afraid, because it's actually good practice, and this way you're going to keep clients happy and yourself not being woken up in the middle of the night. So do not rename fields. Clients expect fields with certain name, or do not delete them, or do not change tag values. Again, this breaks compatibility on binary level, and if client receives the message from the server, it doesn't understand, because client is still using some older protocol version, it will break almost 100%.
I have a question straight away.
Yes.
This immediately leads to kind of legacy technical debt by default. So if you design something in a bad manner, then you want to change it, and you say these are don'ts, and you just end up with, I don't know, 100 field definition, and actually in use it's around 10.
Yes, that's correct. So for this, I think I will mention it a bit later. You need to know how many clients are still using your protocol in production. You need to have some sort of reporting or tracking system, so that each client will tell you its protocol version. I suggest that clients do this, and you need to force them to do it. So let's say you see clients using version 10, there's 0. That means you can drop the support for the protocol below that version. It can happen that, of course, you will have some legacy fields and you're still sending them, but mark them as deprecated so that at least your server developers are aware of this. Yes. So whenever new functionality comes along, introduce new fields for it, describe the changelog properly, but still continue sending old fields until there are clients using it. So there must be a good mechanism to force the clients to start updating. Whether they are, like I mentioned before, sending you the client version and you just have a report with those versions. So this is the last sentence here. So yeah, always force clients to send protocol version to the server. Do not accept clients that don't do that, because you can end up with a pile of legacy fields and code. It may be necessary to create functionality branches in server, because that's how the life goes sometimes. But keep them to a minimum, and again, discuss it with the client developers. Tell them that you want to update. Also check how many clients you have in production. If possible, remove those branches or have some review process every 3-6 months, depending on your business. And it's possible to have integration tests in the code that will do this verification for you. So if when you have a continuous integration and you have integration tests checking support for the required protocol versions, then you are safe to say that you are fine with all clients. But this again is up to developers to maintain those integration tests and maintain them well. A few words about internal protocol and external. So I've already mentioned that we have protocol with clients. I call this external protocol. You need to be careful with this. You need to be careful changing, making changes, removing some old fields. Internally, it's not such a big concern unless your system supports partial upgrade. So let's say you have 10 microservices, and now you're thinking to update half of them. Be careful in this case not to break the protocol between them. If you update them all at once, not an issue. You can change fields, you can delete the old ones. But if you're doing it sequentially during some period of time, always look at the backwards compatibility issue. Okay, so now I'm finished with the theory part. So I would like to show a little demo and some of the examples of the bad protocol design. And maybe you can suggest how to fix them. So again, this is how the message looks like.
Maybe use presenter view or something.
What do you mean?
Develop classes. Presenter view or something.
Or just enlarge the font size.
Yes.
It's Control plus, I guess.
Third last one, end presentation mode.
Add presentation mode, yes.
It's not that much better. Okay, so I'd like to end it right now. Oops. Okay. Okay, I think that's the button here.
Sorry to break your computer.
Yeah. Okay, I think we can live with this. So, what do we have here? Some examples of the bad and good protocol design. This is actually something we faced very recently and we're working still on it. So let's say you have some enums which look very, very similar to you. They have some repeated fields. They even have the same purpose, just with different names. So you have messages called placebets response, tips, action response. They all return very similar enums. So the suggestion here is just use one enum where you will collect all the correct errors for the clients and use it. Because otherwise, first of all, you end up with duplicated code that is difficult to maintain straight away, which is the biggest problem. And also, if you want to add something, again, you have to add it in 3 places, because essentially all those enums are returning error codes for the same operation on the server. So that was a wrong design decision, and it needs to be changed. But the way to change it is, of course, introduce new abstraction. We still have to live with the old values until the clients are using it. Another example. The message is called login request, and it has some strings. Some of those strings are actually can be combined together. And let's say you have another 20 fields in here. So it's better to introduce a nested message where you can put your browser version, browser device, and call it some, let's say, player device info. And of course, the word client can be dropped because it gives no useful information here, because we already know this login request is coming from the client. So this is not necessary. Keep your messages simple. So the fix will be just, first of all, remove the client prefix and then introduce the new message. And again, The next example is using one-off structure. Some of the fields here actually are not generic, which means the fields here would belong to any game, but in this case they belong to a blackjack game, so they need to go into a blackjack payload instead of being here, because it's just wrong to have them here semantically. And I've put a nice sentence here: some forgotten property, no one remembers what it does. It can happen. It has happened and probably will happen again, that some messages in the protocol, no one remembers what they do. So either comment here or good name for it. So right now we're looking at the Maven project that can compile the classes for us. So it's actually quite simple. What I added here is I'm using a proto-stuff compiler. It is not native compiler for protobuf, native with proto-C, but proto-stuff provides you with some flexibility. The very important flexibilities here is that you can define what's going to go into resulting Java classes. This will be happening in this configuration section here. When you use the goal st4, that means the string template library used inside proto-stuff will take what you've written in those STG files and accordingly put it into Java classes. Right now this is the default Java extension provided from proto-stuff, but you can write your own if you extend an interface. The good example here, for example, you have a class which holds user passwords or some sensitive information. No way this information could end up in toString method, because that's going to be logged into console or log files. So you can define your custom extension provider that will actually reduce this information to, let's say, replace this password with stars or does something else, somehow obfuscates it. And that's it. This project can be built, if I can see it now. Right now we don't have any Java classes here. So the generated classes go to target folder. Let's take, for example, our demo profile. There's lots of content in here, but what you get is first you get your builder. The class is immutable, which is boilerplate code you would generally have to write yourself. It took like 5 seconds to generate it. And of course you also have methods with the hash prefix, so you can always check if some field has actually been set or not, which is very convenient. So these classes are generated, they're not to be changed by developers directly, but they're ready to use in your application. And the service example. As you can see here, we're turning Google Guava's listenable future. This can actually be customized. So if you want, you can change the return type to any return type that you want. So if you remember before, in the POM file, we included a file called service stg. This is coming from a separate project, or actually a separate dependency. At the moment you cannot include the stg files directly into your project. Where you have the proto files, they have to come from a separate dependency. So if I can look inside the service stg right now. So this is how it looks like. It's a string template syntax. But again, I've installed a plugin for IntelliJ, so it highlights the important parts for me. Let's say like a service Java name or Java package. And if I scroll down further, this is the return type. So let's say if you want to use Java's completable feature, you can use it. Or if you don't want any return type, you can put void in here. That can also work up to the team. So like I mentioned before, this is compiled as a separate project. It's publicly available. I've posted the links at the end of the presentation so you can check it out. And in the same way, you can completely customize your Java classes. Whatever you want in the Java classes, any methods that are specific for your business, they can go in there. Any questions so far?
I have one. How do you test your protocol files? Yeah, if you test whether you test your protocol files.
We do. I actually will answer this, because why would you need to test your protocol files, first of all, if they are auto-generated?
I mean the message definitions themselves.
Yes.
You eventually write the protobuf files.
Yes.
Then you generate the implementation, right?
Yes.
But what you write, like to generate implementation from,
Mm-hmm.
do you test it or not?
No, we don't. Maybe it does need some testing, but I don't really see the reason why you would want to test it.
So you're going to test if string can be set as a string
Yeah, so this is some sort of pseudocode that you've written. It depends on what you want to test. If you want to test that the syntax is correct, or you want to test that it corresponds to your business requirements.
I mean, I would want to test like if the interface I'm describing is exactly the interface I want to describe.
Okay.
It's basically as you test code. Is
Mhm.
the test is the code that you have written is exactly the code you intended to write, right? It's basically what you test in your code. Here I see like the same motivation to that for testing.
So you use the same messages in the tests, like making generic tests like for some communication.
Mhm. So
In any case where we fill up these messages and improve tests, they will get tested.
So you just test the implementation at it.
yeah, so you can write unit tests, which will actually instantiate those classes, check some methods exist on them. So that's an option.
Thank you.
So I think I'm finished here. I've put the links to the demo code, to Protostuff itself, Protostuff GitHub, and to Google Protobuf documentation. I don't know where I'm going to upload this presentation yet, so I have to think of a good place so that everyone can check those examples. Because unfortunately, Protostuff doesn't have that much documentation available online, so I had to do a bit of research myself. Although we use it in the team, I tried to use the latest version of the compiler of the Protostuff itself and put some basic examples which can be extended to, I would say, any use right now. So, any more questions from anyone?
I have one.
Yes.
So nowadays there are enormous amount of technologies for communication, like from Zoom to Async or whatsoever. Have you made any research before, like why exactly this one? Why not something different?
It's important to note what is different. Let's say if you mean JSON, or let's say Apache, Hessian, or Thrift. It's let's say if you take JSON is text. It sends text over the wire, so it will always be bigger size. Protobuf is very small. So let's say if your system is processing 10,000 messages in a minute, then the size is crucial.
Well, if you have a good system and 10,000 in a minute, even with SOAP is okay.
Or second. When the team started using Protobuf, it was just taken as a good alternative to previous implementation of the protocol. So that's the reason why the team started using it. Because the previous protocol was text-based, so it was a string protocol. And now this is binary, so it's a big step forward. And it, I would say, powers the whole the whole live games right now.
Jonathan was first, then
So my question is whether you have or are internally using protobuf in different languages other than Java as well. And my second question, whether you have looked at gRPC or anything similar.
So the question was, you said do we use it for other anything than Java?
Yes, between different languages.
Okay, so in our server now, we only have our server platform is entirely written in Java. Yes, our dealer application, they compile it to C#. Our Flash clients compile it to ActionScript, and our HTML5 clients compile it to JSON. Yes, so they all have access to the raw proto files, and they build it into the target language. And I think I didn't answer the...
gRPC question, whether you have looked at that.
No, we haven't. Although the protobuf natively, I think, supported.
So the guy on the back.
Is the JSON format?
No, sorry, not you. You're the next.
So, how big of the gains did you receive when you migrated from text-based platform to that binary-based platform?
I would say the biggest gain was for developers themselves. The protocol became a lot more structured, easier to maintain, and less prone to errors. And we were able to discuss protocol changes with Flash developers, iOS developers, HTML5 developers, whoever. They saw the pseudocode, understood the purpose of the change. They proposed some like enhancements of what we wrote. Maybe said no, it's wrong, do it the other way. Then we discussed it. So this was the biggest benefit.
And there was another question.
Is the JSON format using the actual field names or the numbers as keys?
Including field names.
And since the binary format is targeted towards small packet size, is the protobuf doing its own compression?
No, it's not doing compression. It's not that required because the messages will be small anyway. What I did mention is that you need to keep in mind if you have very size-sensitive systems, then let's say any tag numbers from 1 to 15 will take 2 bytes to encode. Then any tags from that number will take more bytes to encode, but the messages are very, very small.
Last question, please.
Am I right in thinking that the versioning thing is for smaller changes? If you need to make a bigger change, then you could define a completely new message type.
Or it's better to define the message.
If you make a bigger change,
So you don't end up with a loss of legacy feeds.
yes, very much depends on the change you're doing. I can give an example. If we develop a new game, let's say some sort of poker game, and of course we'll create a whole set of new messages. And where needed, in places where we need to include these messages, we include them, but it will be basically the whole set of new messages. Yes.
Okay. That's it for the first talk. Thank you so much.
Thank you.
Thank you, guys. This is